So hi everyone, I'm Puneet. I'm developer in this team. So today we are going to see about the changes done to support generic type descriptors. So before jumping into the changes, so I'll just want to brief about what really is a type descriptor. So a type descriptor is metadata about the user defined type. It basically describes how to initialize, copy, destroy, encode, and basically all the type descriptor functions. Type descriptor, it will be generated by default unless if we set this generate descriptor property to false. So this can be located in a properties view and C++ target RTist tab. So there we have a property to generate a type descriptor whether it can be set true or false. And this type descriptor is mainly used in the by the target RTS to copy the data, encode, decode for that use. So that's just a brief about the type descriptor. So now moving to before moving to the changes, so I'll just briefly highlight what are the limitations we have. Currently, before these changes, so it is not possible to have a generically implemented type descriptor with the template parameters. For example, if I have to use a specific instantiation of a template, you can see here in the below screenshot, I added a standard vector int. So if I had to use this, then so I had to create a type alias or a type diff for this instantiation and write all type descriptor functions for all of this. So this is like very tedious and repetitive work. Like you have to add multiple type descriptor functions like copy, decode, encode, etc. And right now in the screenshot. So I just highlighted char and int. So for these two only, so I written like almost 10 functions. So if we have so many like template instantiation, so then we'll end up with so many functions and like it is almost like we're repeating so much of code. So in order to address these difficulties, so we are now introducing uh, generic type descriptor changes. So just to highlight what are the changes, like now since C++ alias type supports template parameters, so this means that with the type descriptor functions, basically these copy, decode, etc. So this can be written as a template function. So which it makes it possible to implement generically, and this will work regardless of the template parameter which is used. And one more point to note here is that since the templates are mostly supported in the header file, so all the code will be generated in the header file, and CPP file will be mostly empty. I'll just show one example here. I have one demo model. So this is a vector library, and I'm using a template parameter t. And you can see here that the H file will be have most of the code, and the CPP will be mostly empty. So another thing to notice is that whenever since now we are supporting generic type descriptor, so sometimes it is required to look up the corresponding type instantiation. So for that, now the target RTS provides a form type function, so which basically helps in locating this. So with this, I'll just highlight this point in when I'm showing the demo. And also you can specify unique name for the template instantiations like standard vector int and char. So this can be one of the handy thing. And this works fine with the Visual Studio compiler, but in GB we have a limitation. So for that, I think you have to use a C++17 feature. And uh, in this point, basically noting down that if template instantiation used as but this point I can show during the demo, like what this limitation is. So any questions? uh, before I jump into the demo. So if not, then I'll jump into the demo. So, just to understand this model, so this model is bit very simple. Like we have capsule one and capsule two, so and the top capsule. So and we are communicating with the protocol, proto, and this has a type alias standard vector, which is basically taking a template argument t, and all the type descriptor functions like copy, decode, distro, encode, etc. are all written as a template functions. So if I look at the example, so you can see here this init, copy, decode, etc. are all written as a template function. So it can work with any parameter which is passed. And so if I look at the capsule one state machine, so in the capsule one state machine, so if I look at the code view, so basically here we are sending the integers, so 1, 2, 3, and which are received at the capsule 2 transition, and these are encoded. These are just printed with the encode. We are calling the encode function and printing with some informative messages. So, and this encode function basically corresponds to what we have in the this standard vector type alias, this encode function. In this encode function, we are just taking the data which is received and writing it as a string. And this is the target RTS function, so which I'm explaining in the slides, so which is basically helps in locating the corresponding template instantiation. So this can be seen here also in the RT object class. Yep, and then in the capsule two, so once we receive this and we are sending the characters, so this characters are again received at capsule one, and same encode function is called, and some informative messages are printed. So you can now see that with this type alias, so we have written like once we written this copy decode, and we are using with different template instantiation. So this is like we are avoiding the repetition, and we are using this with generically it is working fine. So now if I run this code. Yeah, so it works fine. And then if we run it as a, yeah, if we run it as a real-time application, yeah, so we can see that it is successfully able to encode the data and print it. So with this, like we can see that the single encode function is used across different template instantiations, and we are avoiding the repetition of the code. And one more point, so which I was mentioning in the slide, that if any template instantiation is used but passed it as an untyped pointer, so then it may no longer works. So for example, to show this, so here in the protocol, so I have a like data which is basically template instantiation of integer. So right now we are passing it as a native type, and if any of your model is using a native type and without native type and template instantiation, so then it may no longer work. So uh, that is one of the noting point. Yeah, I think that's all about this demo. So, any questions or